For number 11, we're going to need to use two important definitions and one formula that goes with them. So this is a lot about memorizing different math concepts here. So the first thing that most people recognize is that they need to pay attention to the mean, which is the average. We should know that just from normal statistics. Average and mean are just synonyms. They go together. And when we are dealing with average on the SAT, it's important that we write that formula down. The average is equal to the sum of the numbers in our list divided by the number of numbers in our list. So I don't care what words you use to describe the formula, but whatever you use, make sure you still put it on the page. For a lot of questions that involve average, it's going to be really important to work with the formula on the page. Here, because we have the calculator, it's not as important as normal, but I really do think that it prevents careless mistakes to write everything down. So when I do this, I'm also going to write all the numbers on the page for each of the formulas. So let's calculate the average for list A. We'll do that in red. And so the average is going to be the sum of the numbers. So that's 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by the number of numbers. There are 6 numbers in our list. Now, when I enter this in my calculator, and I know I could do this in my head, but just going to show you, 1 plus 2 plus 3 plus 4 plus 5 plus 6. Notice what I'm doing here is just doing the first step in the calculator. I'm not doing the division yet because I like to spread things apart when I'm doing stuff in my calculator. Calculators are really good about following the order of operations, following PEMDAS. But sometimes you're not good at that, and it can make a mistake if you're not really careful with things like parentheses and division and all sorts of stuff. So I think it's just better to play it safe and do one step at a time. It also lets you catch mistakes more easily if you make a mistake and enter something wrong. If the numbers just don't make sense, you have a better way of finding out where you went wrong. So in this case, I just added them up. I got that 21 is the sum, and now I'm going to do 21 divided by 6. To get that the average is 3.5. So yeah, I could have done it in one step on the calculator, but I'm telling you, you're going to make a mistake at some point. Might as well set some good habits at the start. So now we need to do the same thing for list B. So if we knew the formula, then it shouldn't matter. We're just repeating a process here. So the average is 2 plus 3 plus 3 plus 4 plus 4 plus 5, still divided by 6. And again, I'm going to clear my calculator. 2 plus 3 plus 3 plus 4 plus 4 plus 5 gets me 21 again. And so that I don't even need to do. 21 divided by 6 is still going to be 3.5. So these two things are the same. The average of list A and the average of list B, the mean of list A, the mean of list B are the exact same thing. So that's going to get rid of choices C and D for us. No good. The next thing we're going to want to do is figure out what this other idea is, this idea of standard deviation. So this is a term we might be less familiar with. It's not something that comes up often in school, but you do need to know it for the SAT. You could calculate standard deviation, but it's a huge pain and you never need to do it for the SAT. Really, all that matters is that you understand what it means and the broad concept. You'll always be able to know whether standard deviation is high or low just by looking at something. You don't need to actually calculate the value like you might need to with average. So what is standard deviation? Well, we should focus on that word deviation. To deviate is to kind of like move away from something. So when we talk about standard deviation, we're kind of thinking about how much do the points within a set, the numbers within a set, deviate or move away from a certain specific central area. So another shorter way of describing this is that it measures the spread of the data. The best way to show you what I mean is to do some dot plots here. And this is a way of visualizing data. So let's do 2 here, 1, 2, 3, 4, 5, 6. And we'll just do them side by side. 1, 2, 3, 4, 5, 6. This is just basically a number line. Now for list A, which we'll do in red, we just plot the point. So there's a dot for every single point. So there's 1, 1, There's 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. That was easy. Just a line. But for list B in green, something different is going to happen here. There is no 1. There's a 2, and there's a 3, but there's 2 3s. So how do we represent that? Well, we just put another dot right above it. And so the same thing's going to happen for 4. There's 2 dots kind of stacked on top of each other. And then there's 1 5. So just looking at these two sets of data, they look different. Something is visually different between them. So that's not going to bode well for choice B, which says that the standard deviation is the same. There must be some sort of difference. So even at this point, hopefully you would probably lean towards guessing A, but I want to make it clear why A is the answer here. When we talk about spread, we're talking about how the data looks in terms of a central middle. So let's look at list B here. Look at the way that this data kind of smushes towards the middle. There's a peak. We could kind of connect the dots in a way and draw almost like a mountain, right? There's a middle with more data, and then it falls away towards the ends. There's a peak. But if we do the same thing for list A, there's no peak. In fact, you can literally just connect the dots and form a straight line. So which one has the greater deviation? Well, list A has a greater spread. The points are flatter. They're more spread out. So this has a greater deviation. Whereas the peak means that the points don't deviate as much. They bunch together towards some middle, it's not really an average, but it's close. Yeah, it's bunching towards a middle. So this has a lower deviation because it has a taller peak. And sometimes in data, this will be easier to recognize than others, but that's really what you're looking for when you're looking for standard deviation, is you want to see, is there a place where they all kind of smush together? Or is the data more flat, more like a rolling plane instead of a tall mountain peak? The peak is low deviation. The plane is high deviation. I know that that's confusing. This is why this is kind of a hard question, but if you memorize that, you should be good to go. And at the least for this particular question, notice we didn't actually need to know which one was high and which one was low. All we needed to know was that they were different. And so that makes this a little bit easier. I'm just kind of foreseeing where this question is going on a harder part of the test. So I know you still need to know high versus low. So try to file that one away, maybe bookmark this video so that you can come back to it for other questions involving standard deviation. It is something that the SAT really likes to test, so it's worth memorizing.